For this lesson, we're going to look at solving quadratic equations, and now we're going to look at a formula that works for all the quadratic equations, even when it doesn't factor. It's actually based and developed through completing the square, and the formula is called the quadratic formula. So our objective is to be able to solve quadratic equations using the quadratic formula. So what we'll do is we'll be solving ax squared plus bx plus c equal to 0, looking at the a, b, and c, and the formula is that x, every time we solve for x, is going to be the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This formula is going to be something that you need to memorize. We will keep coming back to using it different times in this course. You'll use it in following courses. You'll use it throughout your mathematics career. So get to know this formula, make sure you have it memorized. Also, you need to show your work and be careful when you're simplifying fractions. Fractions can be tricky. You got to make sure you follow the rules of fractions to simplify them correctly. All right, so here's an example here. We're going to do this example by factoring, completing the square and quadratic formula. You can do each of these this way. One of the points that we'll get to through this is if you can factor, oftentimes that's the easiest way. If you can't factor, then you'll need to pick one of the other two. So on this one, to factor, what I'm going to do is I'm going to take out a 2. And then I'm going to factor this using my patterns that when you have a 1 in front of the x squared, you're looking for two numbers that multiply together to give you 2, add together to give you 3. That's a plus 2 and a plus 1. Don't set the 2 equal to 0 because it doesn't have an x with it, so 2 does not equal 0. If it had an x, you'd set that equal to 0, but this one you don't. So it has to have a variable. So x plus 2 equals 0, so x equals negative 2. X plus 1 equals 0, and so x equals negative 1. Now, there's our two answers. I'm not going to change for these different forms, but the technique will change. So if I take this 2x squared plus 6x plus 4, and I want to solve it by completing the square, the first step is to get the constant on the other side and keep the x squared and the x term, the quadratic and the linear term together. So we have 2x squared plus 6x equal to negative 4, and then you have to divide everything by the coefficient in front of the x squared. So you're going to have x squared plus 3x equal to negative 2. You divide everything by 2. Now we can complete the square. Now what makes this one difficult is that this one's going to involve fractions, because when we take the half of the 3, we're going to get 3 halves. So that won't be quite as, it'll be a little bit more clumsy to work with than the factoring was. So half of 3 squared, that's going to be squared. So 3 halves squared is going to be 9/4. Add that to both sides. Now, negative 2 in terms of fourths, we want to get a common denominator when adding those two. So negative 2, just as a reminder, that's going to be negative 4. When we put it over fourths, we multiply by 4 over 4, we get negative 8/4. Added to positive 9/4 will give me 1/4. And over here, this will factor into x. The half of this is what goes in the factorization. So 3 halves, I'm going to have plus 3 halves here, squared. So just remember, when you take the half, that's always what this factors into, because it'd be difficult. You could factor this, but it'd be difficult because it's a fraction. Now we take this to solve it by perfect squares. We're going to take the square root of both sides. So x plus 3 halves equals plus or minus the square root of 1/4. Square root of 1 is 1, square root of 4 is 2. So we get 1/2. and now I subtract 3/2 from both sides, so I get negative 3/2 plus 1/2, or negative 3/2 minus 1/2. Well, negative 3/2 plus 1/2 is going to be negative 2/2. That's going to be a negative 1. And then negative 3 minus 1 gives me negative 4/2, which would be negative 2. So I still get the negative 1 or negative 2 for an answer, just like we did here. Involves fractions, so that can be a little bit clumsy. Now the quadratic formula, this one involves just using the formula, and you just have to be good at simplifying fractions when you use this. The problem with quadratic formula is if you make an error in the calculations, or if you make an error in simplifying the fractions. So on this formula, a is equal to 2, our b is equal to 6, and then our c is equal to 4. For these two, ax squared plus bx plus c. Now we're going to substitute that into the quadratic formula. So you get x equal to the opposite of b plus or minus the square root of b squared, which is 36, minus 4 times 2 times 4, 4ac, all over 2 times a, 2 times 2. So that's going to give us negative 6 plus or minus the square root of 36 minus, this would be 8 times 2 is 32. So we're going to get the square root of 4. This would be 30, I'll just write it out. 36 minus 32 all over 4. Okay, you have to show your work, but there are steps that you could skip. So if you got that square root of 4, you could just write that. Just make sure you're precise on it. Now, the square root of 4 is equal to 2, so we're going to simplify that. Negative 6 plus or minus 2 over 4. It's going to look a lot like this problem over here, just with 4 as my denominator. So negative 6 plus 2 over 4, or negative 6 minus 2 over 4. So negative 6 plus 2 is negative 4. Negative 4 over 4, which is equal to negative 1. Negative 6 minus 2 is negative 8 over 4, which is equal to a negative 2. So there's my answer for this one. So notice they get the same answer. This has significantly less work to it if you understand the process of factoring. The problem is not everything factors. So if it doesn't factor, or if you just want to just make sure you can do it, you have to use one of these two methods. All right, so let's use quadratic formula now to do another example here. Okay, so let's try this. 3x squared minus 7x equals negative 5. So we get 0 on one side first. That's a theme for solving equations, so add 5 to both sides. Then my a equals 3, my b equals negative 7, and my c equals 5. So we're going to put that into the quadratic formula to solve. Opposite of b is positive 7, plus or minus the square root of b squared. Remember, I'll write this one out just because we're going to have people make this mistake. You have to make sure you're going to square the entire quantity, negative 7. So if you're going to put it in your calculator, put it in parentheses, because that's going to be a positive. If you don't put parentheses on, your calculator is going to give you a negative. Okay, minus 4 times 3 times 5, 4ac, all over 2 times 3. Let's go ahead and do some simplification. 2 plus or minus the square root of 49, minus 4 times 3 is 12, times 5 is 60, all over 6. All right, now we have for this, it becomes 7 plus or minus the square root of negative 11. Notice that this one would not factor because you get actually an imaginary number in this part of the problem. So it'll be complex for an actual answer. So what do you do when you have the square root of a negative? You take the I out. So I'm going to have 7 plus or minus I square roots of 11 all over 6. Now, let's go and write it in the form that we like to write it, and I'm gonna write it. You can leave the plus or minus in it, or you can separate it. I'm gonna separate it here. I'm gonna have 7 over 6 plus square root of 11 over 6i. That's a plus bi form. Or the other one would be 7 over 6. So put 7 over 6 and then this over 6 minus, so the minus one, square root of 11 over 6i. And you could just write it, I'll just write it out here. The other option is to write 7, 6 plus or minus square root of 11 over 6i. So here's my possibilities for answers. So notice that this is a complex answer. It's got an imaginary part to it, and so that would not be able to be factored as part of the problem. So let's go ahead and talk about how we classify these roots. So this really is, you'll be asked to classify the roots of equations. When you do that, you're going to use the discriminant, and the discriminant is b squared minus 4ac, not the square root of b squared minus 4ac. Notice back to this equation, when you look at the quadratic formula, what determines whether this is going to have an imaginary part is whether we get a negative under that square root. So that discriminant is going to be what determines whether we get that imaginary part, or even on this one, notice it was a perfect square. We got the square root of 4. It came out of that square root because we know the square root of 4. It became a rational number. So it also will help determine whether it's rational or irrational. So we're going to use just not the square root, but the b squared minus 4ac. We'll call it the discriminant because it helps us to discriminate what the solutions are, and we're going to use that to classify, are the roots imaginary, are they real, are they rational, are they irrational? Let's go ahead and set up a chart for this. So this one here we're going to do for the value of the discriminant. If the value of the discriminant, so the b squared minus 4ac, if it's greater than 0, okay, that means we have, it's going to be positive. I'm also going to say, and a perfect square. So a perfect square would be like this example up here where we got the square root of 4. 4 is a perfect square. It came out of the square root, so we now had a rational number as an answer. So if that's the case, the number of roots we're going to have, there's going to be 2 roots. They're going to be real, but we're going to be more specific. They're actually going to be rational roots. 2 rational roots. The visual on this is that when we cross the axis, okay, you're going to cross the axis at an actual rational number. So it's going to be some value where you're going to have, say, p over q, something like that, that turns out to be a fraction. It could be -3/2 and +4/5, but it's a rational number that you get when you have a perfect square that's positive. But what it does do is it crosses the axis twice. That's why there's 2 roots. Right? What if the discriminant is greater than 0, so it means it's positive, and not a perfect square? That means we're not going to be able to get not a perfect square. So we're not going to be able to get the square root cleared up. It's going to say have a square root of 5 or square root of 31 in it. You can't get rid of the square root. That means you're going to have 2 irrational roots. Whereas these were rational numbers where it crosses the axis. This one would be, it would cross the axis. Again, it doesn't always have to be symmetric around the axis, but where it crosses here, these are irrational numbers. for the x-intercept. So there's two of them because it crosses the x-axis, but they're going to be answers that are going to be irrational numbers. All right, so the visual, what if we have b squared minus 4ac equal to 0? Well, that means you're going to just get one answer, because if you look at your quadratic formula, it's going to be plus or minus the square root of 0, which is plus 0 minus 0, same thing. You don't get two different answers. So this is going to be one rational root, because 0 is a perfect square. And we often call this a double root. It's like that root is happening twice, because this is where perfect squares happen. Like you might be able to factor into x plus 3, the quantity squared, instead of factoring into two different numbers. On the graph, this is where the graph comes down, hits the axis at a value, and then keeps going. So this would be where you would get just one rational root, where it just hits the axis once. And the last category down here, you probably could guess what it would be. We've gone positive, we've gone 0, let's go negative. So if this one's less than 0, which means it's negative, that means that we're going to have two complex conjugate roots. So this means that what happens is that you might have, for instance, 2 plus 3i over a number and 2 minus 3i over a number. So they're going to be conjugates when it comes to the answers. And the way this looks graphically, since they're not real solutions, is that it's going to be the graph never touching the x-axis. There's no x-intercept on the graph. That's what happened on this one. If you were to take the time and graph this 3x squared minus 7x plus 5, you'd see that this graph never touches the x-axis. All right, let's take a look at a couple examples down here. We're just going to classify these. We're not going to solve. That's what people have to get used to when it says classify. You're just going to look at the discriminant. So the discriminant d is going to equal, again, b squared minus 4ac. That's the radicand of the quadratic formula. So my b here is 12, so 12 squared minus 4 times 1, which is a, and 36, which is c. Okay, when I simplify that, I get 144 minus 144, which is equal to 0. So looking at our chart, when it equals 0, that means we have one rational root. That's all you have to do. Determine what the discriminant is, and then look at your chart there and determine how is it classified, one rational root. All right, let's look at this one. We gotta get 0 on one side first. So 2x squared minus 3x plus 10 equals 0. So on this one, my a is 2, my b is negative 3, my c is 10. So my discriminant is equal to negative 3 squared minus 4 times 2 times 10. So that's going to be 9 minus, this is going to be 80. So 9 minus 80 is going to be a negative 71. Since I get a negative value for that, that's going to be two complex conjugate roots. So what we've done with this lesson is we took a look at our standard form of equations for quadratics, and we now have a new way of solving them using the quadratic formula. That quadratic formula is based on completing the square. So you can factor to solve quadratics, you can use the completing the square, you can use quadratic formula. Factoring doesn't always work, not everything factors, so completing the square quadratic formula will always work. And then we looked at how we can classify them, looking at a table like this by looking at the discriminant, which is just this b squared minus 4ac. That discriminant will tell us, depending on what the value of it is, of how many roots we have and the classification of what number set they fall into.